Before going to discuss about formula in details, I am going to discuss one important topic here, that is magnification. The term is magnification, and magnification is defined as the ratio between the size of image to the size of object. Size of image to the size of object can be written as m equals to h dash by h, where h represents size, or we can say height of object. H represents size or height of object. H dash represent size or height of image. So what is magnification? If I ask you, ratio between size of image to the size of object, and you should know that it has no unit. Why it has no unit? Because it is the ratio of two similar physical quantities, size by size. So if you use the unit, the same unit has to be used, units gets cancelled, and thereby magnification has no unit. Magnification is given by another formula, m equals to minus v by u for spherical mirrors, and the proof of this formula will be discussed in higher classes. So m equals to minus v by u we are discussing for class 10. In the syllabus it is not given, so we'll discuss in higher classes. So m equals to minus v by u, where u represents object distance. U represents object distance and v represents image distance. Image distance. So if I ask you formula for magnification, first one m equals to h dash by h, and second one m equals to minus v by u for spherical mirror. You should note down the definition and formula. Now we will discuss different formulas that are related to spherical mirrors, and if you understand that formula properly and new Cartesian sign convention, you will be easily able to solve different numericals related to spherical mirror. And the formula are that we are going to discuss. First one, 1 by u plus 1 by v, 1 by u plus 1 by v equals to 1 by f. This formula is called spherical mirror formula. This formula is called spherical mirror formula, okay, where u represents object distance, v represents image distance, f represents focal length, f represents focal length. Second formula, f equals to r by 2 or r equals to twice f. In case of spherical mirror, focal length is half of the radius of curvature, or radius of curvature is twice of the focal length. If you look at here, this is concave mirror, principal axis, pole, focus, center of curvature. Radius of the sphere of which spherical mirror is a part is called radius of curvature. So C or P ka length, radius of curvature, f or p ka length, focal length. In case of spherical mirror, concave and convex mirror, focal length is always half of the radius of curvature, or radius of curvature is twice of the focal length. Third one that we already discussed, m equals to h dash by h, where m is what? We already know m is magnification. M is magnification. If I ask you what is h here, h is size of object. If I ask you what is h dash here, it is size of image. Another formula, m equals to minus v by u. Another formula for magnification, m equals to minus v by u, where u represents object distance and v represents image distance. Okay, so 4 important formula we discussed. First one, 1 by u plus 1 by v equals to 1 by f. Second one, f equals to r by 2 or r equals to twice f. Third one, m equals to h dash by h. And fourth one, m equals to minus v by u. Note down this formula properly, and we will discuss new Cartesian sign convention after this. So before going to start new Cartesian sign convention for spherical mirrors in detail, I suggest you to note down these important points related to new Cartesian sign convention. Point number 1, all the distances are measured from the pole of a spherical mirror. So these are spherical mirror, and all the distances are measured from where? They are measured from pole. Suppose the object is placed here, I have to measure the distance from the mirror, I have to measure the distance from the pole. So point number 1 of new Cartesian sign convention, all the distances are measured from the pole of the spherical mirror. Point number 2, all the distances measured in the direction of the incident ray are taken as positive. As we know that distances are measured from pole, and any distance which is measured in the direction of the incident ray. So if I measure distance of this object, I have to move in the direction opposite. If I have to measure distance of this image, I have to move in the direction of the incident ray. So all the distances measured in the direction of the incident ray are taken as positive. Third one, all the distances measured opposite to that of the direction of the incident ray are taken as negative. So अगर distance measure किया जाता है incident ray का path में, उसी direction में pole के वहाँ से, तो हम लोग positive लेंगे, और इंसिडेंट रे के ऑपोजिट डायरेक्शन में अगर हम लोग को डिस्टेंस मेजर करना पड़ा तो उसको हम लोग नेगेटिव लेंगे. पॉइंट नंबर 4, ऑल द डिस्टेंसेस आर मेजर्ड अबव द प्रिंसिपल एक्सिस आर टेकन एज पॉजिटिव. All the distances, point 5, all the distances are measured below the principal axis are taken as negative. So here this object, height of the object above the principal axis, it is positive. This image, height of the image below the principal axis, it will be taken as negative. So I suggest, I advise you, first note down these points and then we will discuss these points in detail. Now we'll discuss application of new Cartesian sign convention in the formula of spherical mirror. So for concave mirror, this is principal axis, pole, focus, center of curvature, xy is the principal axis, and this is concave mirror. Concave mirror. If I place an object here, image is formed here. Okay. If object is placed between center of curvature and focus, image is formed beyond center of curvature, and the direction of incident ray will be this, because light rays fall on the mirror, or they reflect from which side? Side opposite to that of the polished surface. So this side is polished and this is the opposite surface, incident ray will fall here, get reflected. So if I place an object here, image is formed here, and according to new Cartesian sign convention, all the distances, सभी distances को कहाँ में से measure करना? We have to measure all the distances from pole. So ये object, pole से object का distance को हम लोग बोलेंगे object distance. That is denoted by symbol u. तो u का जो भी वैल्यू होगा, जो भी मैग्नीट्यूड होगा, उसको पॉजिटिव लेना चाहिए या नेगेटिव, अकॉर्डिंग टू न्यू कार्टेशियन साइन कन्वेंशन. साइन कन्वेंशन हम लोग को बताता है कि कोई भी डिस्टेंस इंसिडेंट रे के ऑपोजिट डायरेक्शन में अगर हम लोग मेजर करेंगे तो उसको नेगेटिव लेना है, ओके। और सभी डिस्टेंस कहां से मेजर करना है? ऑल द डिस्टेंसेस आर टू बी मेजर्ड फ्रॉम पोल। नाउ ये इमेज फॉर्म हुआ और पोल से इमेज का डिस्टेंस को हम लोग बोलेंगे इमेज डिस्टेंस डिनोटेड बाय सिंबल v, डिनोटेड बाय सिंबल v। सो यहां पे भी इंसिडेंट रे का ऑपोजिट डायरेक्शन में मेजरमेंट लेना है, सो इट इज टेकन एज नेगेटिव। अगर आपको पूछा जाए फोकल लेंथ पॉजिटिव होना चाहिए नेगेटिव, तो फोकल लेंथ भी नेगेटिव ही होना होगा, बिकॉज दिस इज फोकस। पोल से फोकस का लेंथ को हम लोग बोलेगा फोकल लेंथ, एंड पोल से ही मेजरमेंट करना है, सो ऑपोजिट टू द डायरेक्शन ऑफ द इंसिडेंट रे, सो इट इज नेगेटिव। दिस पॉइंट इज सी, सेंटर ऑफ कर्वेचर। पोल से सेंटर ऑफ कर्वेचर तक का जो गैप है, जो लेंथ है, उसको हम लोग बोल सकते हैं रेडियस ऑफ कर्वेचर। उसको हम लोग क्या बोल सकते हैं? रेडियस ऑफ कर्वेचर। एंड दिस रेडियस ऑफ कर्वेचर इज ऑल्सो टेकन नेगेटिव। व्हाई? हियर ऑल्सो द डिस्टेंस इज मेजर्ड इन द डायरेक्शन ऑपोजिट टू दैट ऑफ द इंसिडेंट रे। सो फॉर कॉन्केव मिरर u is always negative because object is placed on this side, and object distance will always be measured in the direction opposite to the direction of the incident ray. We can consider one more situation, especially for virtual image. We can consider one more situation for virtual image. This is concave mirror, and this point is pole, focus, center of curvature. If we place an object between focus and pole, we know that a virtual and highly magnified image is formed behind the mirror. So object अगर focus और pole के बीच में होगा, image कहाँ form होगा? Image will be formed behind the mirror. In this case, if I ask you object distance should be positive or negative, the answer is negative because it is measured opposite to the direction of the incident ray. If I ask you image distance will be positive or negative, the answer it is positive. Object distance negative होगा, image distance positive, क्योंकि image right side में form हुआ है, तो pole से उसका distance measure करने से we have to move in the direction of the incident ray. Incident ray का direction में ही अगर move करेंगे pole से, तो उस distance को हम लोग को positive लेना है. Now this is focus, so focal length will be positive or negative. It is negative. Radius of curvature positive or negative. It is negative. Now if you look at here, height of object को represent करता है हम लोग h से above the principal axis. Above the principal axis, the measurements are taken positive or negative according to sign convention, positive. ये रियल इमेज फॉर्म हुआ है. रियल इमेज का हाइट को हम लोग h डैश से रिप्रेजेंट करते हैं, और इमेज का हाइट बिलो द प्रिंसिपल एक्सिस, इट इज द मेजरमेंट विल बी टेकन इन नेगेटिव. In this case, height of object is positive and height of image is also positive because it is above the principal axis. So for specially we have discussed specially for concave mirror, and for concave mirror you can write u is always negative. V negative for real and inverted image. V negative for real and inverted image. V positive for virtual and erect image. Okay, so u always negative होगा, v का magnitude always negative होगा अगर image का nature real and inverted. V positive for virtual and erect image. F is always negative, R is also always negative. So this is sign convention for concave mirror. while solving numericals you will have to apply this sign convention. अगर पूछा जाए height of object का sign convention क्या होगा, height of object के लिए always positive, height of real image h dash is negative for real and inverted image, and h dash is positive for virtual and erect image. Okay, so this is very important part. If you don't understand this part, it will be very difficult for you to solve numericals. Note down everything properly with these diagrams. Now we will discuss new Cartesian sign convention for convex mirror. And you should know one thing, that a convex mirror always produces virtual, erect, diminished image of an object placed in front of it. So convex mirror always कैसा image बनाता है? Convex mirror always virtual, erect and diminished image. Object अगर यहाँ place करें anywhere in front of the mirror, image is formed between focus and pole. Convex mirror always forms what kind of image? Virtual, erect and diminished image, and the image is formed behind the mirror. Image is formed behind the mirror. So we are discussing new Cartesian sign convention for convex mirror. Okay, so this will be the direction of incident ray. इंसिडेंट रे तो इधर से ही आएगी. सो ऑल द डिस्टेंसेस आर मेजर्ड फ्रॉम पोल. तो पोल से ऑब्जेक्ट का डिस्टेंस, ऑब्जेक्ट डिस्टेंस पॉजिटिव लेना चाहिए या नेगेटिव? अकॉर्डिंग टू साइन कन्वेंशन इसको नेगेटिव लेना होगा. क्यों? बिकॉज फॉर मेजरिंग दिस डिस्टेंस वी हैव मूव फ्रॉम पोल एंड ऑपोजिट टू द डायरेक्शन ऑफ द इंसिडेंट रे. तो ये पोल से ये डिस्टेंस इमेज डिस्टेंस, और इमेज डिस्टेंस पॉजिटिव लेना चाहिए नेगेटिव? पॉजिटिव. क्यों? इमेज डिस्टेंस इज टेकन पॉजिटिव बिकॉज टू मेजर इमेज डिस्टेंस वी आर मूविंग इन द डायरेक्शन ऑफ इंसिडेंट रे फ्रॉम पोल. फोकल लेंथ पॉजिटिव होना चाहिए या नेगेटिव? इट इज पॉजिटिव. रेडियस ऑफ कर्वेचर पॉजिटिव और नेगेटिव? इट इज ऑल्सो पॉजिटिव. Because to measure focal length and radius of curvature from pole, we have to move in the direction same as the direction of the incident rays. So according to new Cartesian sign convention, F should be positive, R should be positive for convex mirror. Now height of the object is positive and height of the image is also positive. Why height of the image is positive? Height of the image is positive because image is always virtual and erect. So for convex mirror, U क्या लेना है? U always negative ही लेना होगा. V क्या लेना होगा? V always positive ही लेना होगा. F is always positive. R is always positive. आपको अगर पूछा जाए height of the object क्या लेना है यहाँ पे? It is always positive. Height of the image is always positive. Why? Always virtual, erect and diminished image is formed by convex mirror. So while solving numerical, this information is very important. For convex mirror, U is always negative, V is always positive because always virtual and it is always formed behind the mirror. F is always positive, R is positive. Height of the object is positive and height of the image is also positive. Now we can note down new Cartesian sign convention, how it is directly applied to the magnitude, especially for concave and convex mirror. First for concave mirror, U is always negative, V is negative for real and inverted image, real and inverted image, V is positive for virtual and erect image, F is always negative, R is always negative. When you are solving numericals related to concave mirror, you will have to apply sign convention like this. For height of the object, it is always positive. Height of image, negative for real and inverted image. And H dash will be positive for virtual and erect image. When you are solving numericals related to convex mirror, if you are solving numericals related to convex mirror, U is always negative, V is always positive, F is always positive, R is always positive. A convex mirror never forms real image. It always forms virtual and erect image. Thereby V, F and R, they are always positive because F is behind the mirror, R is also behind the mirror. Then height of the object is positive, height of the image is also positive. Since it always forms what type of image? Virtual and erect image. So to solve numericals, you will have to apply these sign convention for the different magnitude given for different measurement like object distance, image distance, etc. In this part, I am going to discuss how to apply new Cartesian sign convention for magnification. So magnification, we already know magnification is the ratio between size of image to the size of object. Another formula, m equals to minus v by u for spherical mirrors. And you should know that m is negative for real and inverted images. One more thing you should know, in case of spherical mirror, real and inverted images, they are formed in front of the mirror. Okay, so m is negative for real and inverted images, and real and inverted images are formed in front of mirrors. M is positive for virtual and erect images, and the virtual and erect images, they are formed behind the mirrors. So m is negative for real inverted images, m is positive for virtual erect images. I am discussing some example where if I ask you m equals to minus 1, what do you mean by this? If I get the value of m as minus 1, we know that there is no unit for magnification, but what is the meaning of this negative sign? What is the significance of this value 1? This minus sign represents real and inverted images. So m minus 1 indicates the size of image is equal to the size of ऑब्जेक्ट. ये कैसे पता चला? m का वैल्यू 1 कब होगा? जब ये दोनों का वैल्यू सेम होगा. इमेज का साइज और ऑब्जेक्ट का साइज सेम होना चाहिए, तो m का वैल्यू 1 होगा. और इस नेगेटिव साइन का सिग्निफिकेंस क्या है? द इमेज इज real and inverted. The image is real and inverted. Now if I ask you m equals to minus 2, What do you mean by this? यहाँ the size of image is double, the size of image is double compared to the size of object. इमेज का साइज और ऑब्जेक्ट का साइज में क्या है, यहाँ पे 2 से क्या इंफॉर्मेशन मिला कि इमेज का साइज ऑब्जेक्ट का साइज से डबल है. दैट 2 रिप्रेजेंट्स दैट, एंड माइनस साइन इंडिकेट्स व्हाट, द इमेज इज रियल एंड इन्वर्टेड. So अगर आपको पूछा जाए m equals to -1, what do you mean by this? This minus sign indicates real inverted image, and 1 indicates the size of image is equal to the size of object. Here 2 indicates the size of image is double to the size of object, and minus sign indicates the image is real and inverted. अगर आपको बोला जाए m is equals to 1/2, what do you mean by this? या फिर आपको पूछा जाए m is equals to -1/3, what do you mean by this? So here plus sign indicates virtual erect image, and half indicates the size of image is half of the size of object. और हम लोग बोल सकते हैं कि size of image is 2 times smaller than the size of object. यहाँ m equals to -1/3, minus indicates real and inverted image, 1/3 indicates the image is 1/3 of the size of object, or the image is 3 times smaller. So m equals to 1/2. Here it indicates the size of image is 2 times smaller compared to the size of object, and the image is virtual and erect. The image is virtual and erect. M equals to -1/3. This indicates the size of image is 3 times smaller. The size of image is 3 times smaller compared to the size of object. Compared to the size of object, and the image is real and inverted. The image is real and inverted. This concept of magnification, how to use positive and negative sign, and what is the meaning of these different values, you should know that this will definitely help you in solving numericals.